Today we're going to be looking at another heavily requested Styropyro video. Specifically, another crazy laser video. This one called 2020 World's Most Powerful CW Handheld Laser. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's get right into it.
When we think of technological advancement,
oh wow, look at all the old phones.
We usually think of our electronics getting smaller and more powerful. Now lasers are no exception to this. With high power lasers,
I like that he said that and he showed the picture of the phones getting a little bigger.
becoming more efficient and available in smaller packages. Recently, I was able to score an engineering sample for this absolute monster of a blue laser diode array, rated for a whopping 95 watts of output power, and probably capable of quite a bit more than that. So naturally, I want to jam this thing into a tiny housing for a hilariously dangerous laser pointer. Now in fact, going off the rated output power alone, this thing should actually make for the most powerful CW handheld laser in the entire world. So yeah, without further ado, let's get to building. Oh yeah, I should warn you that all the crazy stuff that you're about to see was done completely for educational purposes. In fact, if you were to try any of this stuff at home, you'd probably die. So yeah, please don't try this at home.
If you were going to try to use lasers, if you're going to do a laser project, say at the nuclear power plant that I worked at, you would need to go through extensive safety training, practical exercises, written exams, get and obtain a certification just on the lasers themselves, and also on, gonna call it nuclear power plant etiquette, if you will. That is to say, using the device only when directed by your testing procedure for whatever equipment you're trying to test using the laser, or whatever maintenance activity you're using the laser with. Everything is very prescripted, and if you want to deviate, well, you can't. You have to basically get your documents updated. I couldn't imagine someone with the energy and freedom to do what he wants with all of his little projects like Styropyro to be in a role like that. So it's a very different world, but one of the many reasons why I find Styropyro's project so fascinating.
Now there's some shady stuff going on with this crazy laser diode array, because it's apparently made by Nietzsche, but if you actually go to the website, there's actually no information available on this part. In fact, this data sheet here was just given to me by the person who sold it to me. So that means that either this part's fake, or the public just isn't supposed to have these things yet. And now going off of past experiences with powerful laser diodes, I'm actually going to bet it's the latter. But either way, it can't hurt to fire this thing up just to make sure it works.
Wow, that's crazy.
Alright, so I strapped the laser array onto this heatsink here and then added some test leads. Now this silicone thermal padding isn't exactly ideal, but I won't be running this thing very long for this little test. Alright, I have it sitting just below threshold there. It is now ready to fire up. Alright, here goes nothing. Oh jeez, wow, look at that beam!
That is
Man, it's lighting up the whole room there too.
Each one of those little tiny thingies is so intense. Wow.
Insane. And gosh, what's that, like 10-20% of the rated power? Oh man, oh, this thing is gonna look ridiculous at
look at it with the little plasma disc in the background. It's green. Yeah, each one of those, even an individual, is gonna mess with your eyes.
Power. Wow. Oh, and check that out. You can see all the little beamlets there too. I wasn't expecting those to be so visible. Oh man, wow. Oh, oops, I better kill it before I light that beam stopping fire. Now, it's funny because part of the reason why this array even exists is to prevent hobbyists from using them. Now, it turns out that one of the biggest uses of blue laser diodes is in hybrid DLP projectors, and the manufacturers are sick of us tearing them apart for the lasers. I guess what little money that they make from those sales just isn't worth the bad publicity if somebody gets hurt. Now, by combining all the lasers into one small part, they think that they can stop us from using them, and in fact, this is explicitly stated on some data.
This is another reason why nuclear materials are so heavily controlled, is you don't want people tinkering with them and getting hurt. I mean, look at all those orphan source incidents as a result from poor tracking of radioactive material, whether it be from a nuclear power plant, a military's nuclear weapons program, or radiation therapy. In that case, that one incident that happened in Brazil where people saw the cool glowy thingy and wanted to touch it, and the glow dust, and it ended tragically.
Heats for laser diode arrays. Now what they don't account for is cycles like me that'll just run the entire array at once using a giant battery pack. On the thermal cam, you can see that it doesn't take long for this laser to heat up, and really that's no surprise considering the extreme power density of this little unit. Now since laser diodes hate heat, I'm going to have to be extra careful that I don't bake the poor thing when it gets put inside the laser pointer housing. Alright, so that's enough screwing around for the time being. It's time to get to building. For the laser's housing, I'm going to use this sweet retro-looking radar gun that my friend scored from a junkyard. Now amazingly, this thing was actually in use till just a couple years ago. Now at least according to this Now
can you imagine using that to check the light speed limit, and if it's going faster than light, then you need to pull it over for a ticket? You'd have a whole lot of other problems if that were the case.
sticker here. Now why it got thrown away I'm not quite sure. Maybe it finally broke, or maybe just got replaced by something newer. But either way I'm just thankful that it got saved before meeting the trash compactor, because this thing is just way too cool to get scrapped for its metal content.
Oh yeah.
I went ahead and tore down that radar gun there, and I have to say, there's a lot of cool stuff inside this thing. For one, you have these old school through-hole PCBs, and then obviously this really nifty microwave horn here. And there's even some maintenance logs here that go back to the 90s. And check this out. If you look at this board here, it says it was made in 1985. So that means that this thing was being used for like 35 years in the field, which is actually really impressive.
Wow.
Now, I won't be needing most of the parts on this thing, other than this switch.
Say what you will about some of this old equipment, it was more built to last. Run into that with little bits and pieces from old components at a nuclear plant, and the problem is, when they eventually do break, finding replacement parts, because people forget how to make them.
Here, and then obviously this really cool casing. This is essentially going to be a scaled up version of my other giant handheld lasers. So along with the laser array, I need to fit in a power source, a current driver, and some method of cooling. Now this isn't exactly going to be easy, since a 100-watt laser in a handheld unit is literally insane. Like that's the same output power as this monster surgical laser over here.
100 watts is huge for a laser. Taking a big light bulb and focusing it to lasers, yeah.
Heat is going to be the biggest issue here, since I'll be feeding the laser about 300 watts. Now of that, a little over a third of that power is going to be emitted as laser light, which is actually really efficient. But still, that means there's an extra 200 watts of heat plus whatever's wasted in the drivers to get rid of. Now if I were building this into a benchtop unit, I'd use TEC cooling or even liquid cooling for solid thermal regulation. But this just isn't practical in a handheld unit, since that would actually generate more total heat to deal with.
Not to mention liquid cooling for a handheld thing is super heavy.
I'm going to resort to using a big heatsink. As for coming up with the right heatsink, I suppose you could take some measurements and make a 3D model that could be CNC'd. But who am I kidding? I don't know anything about 3D modeling software. And besides, power tools are a lot more fun. So I'm just going to hack at this hunk of aluminum here until it fits in the housing.
That's awesome. Just turn them all on at once. Okay, I know this is all supposed to be silly, but just, oh man, I'm not sure I can get through this. Forget your 3D printer, I'm just gonna throw every tool I have at this thing and maybe something will happen. We're bringing the occult into this? I'm both surprised and not surprised. There we go. Excellent music choice.
Alright, so here's the completed
I think that display of madness was the reason why this was so heavily recommended. I'm sure of it.
sink. Now, is it ugly? Well, yeah, but part of the reason why I'm using this radar casing is so you can't tell that it's total trash on the inside. Now, since space is so limited, I'll be attaching the drivers to it also. Now, you can't just hook up laser diodes to a battery and expect them to survive more than a second. You need some sort of current regulation. Now, there are a lot of ways to make a constant current driver, but I ended up going with LM338s, which actually isn't as stupid as you might think. Now, for one, they're simple to implement and provide a steady output, but they're also surprisingly efficient when ran at the higher end of the rated voltage, and along with a small input to output voltage differential. I decided to run the laser diodes at 3.2 amps per string, which is pushing them a bit since the manufacturer only suggests 3 amps, but I'll only be running them for short increments of time. Now, I'm taking this risk since I really want to clear the elusive 100 watt mark, which has likely never been done in a handheld laser. Now, going off of the stated slope efficiency curve, driving the laser diodes at 3.2 amps should give an output power of 101.8 watts.
Now this is, I know if you've watched one of my other Styropyro videos, he has pulse lasers that you get numbers into the megawatts, but at that point you're just dividing by a really small number. This is a sustained beam of laser, which is why 100 watts here, there's a lot more energy that is going on in this sort of thing. It's like having super inflated numbers where you can have an atomic bomb have a wattage equivalent to 1% of the luminosity of the sun, but the sun produces energy over the course of billions of years, not billionths of a second. So there's your difference.
Yikes. Alright, so here's a quick rundown of what the circuitry looks like inside. So I stuck a voltmeter here to read the voltage of the batteries. Then right here's a thermometer to read the temperature at the laser diode array. Now I stuck a lot of switches on this thing. This is the main power switch here. Then I used this switch that came with the unit as a safety switch. That also feeds into a indicator LED that's on the front here. Now as for the trigger, I didn't quite trust it to handle the high current that those lasers were going to take, so instead I just have it signaling to this massive MOSFET here to handle the bulk of the power switching. As for mounting the laser array, I need to be absolutely sure I can wick away the heat as fast as possible to the aluminum. I ended up using what the pros use, indium foil. Now indium is excellent for thermal bonding since it's extremely soft, like you can cut a bar of it with a butter knife. Now by bolting down the array over a sheet of indium, the indium spreads out to fill voids in left from my imperfect machining. Now that I got everything mounted, my final task is to add a beefy source of power for this circuit. Now this is where lithium battery tech saves the day yet again, as powering this 30 volt 13 amp circuit is a cakewalk for these two batteries here. Now in theory I should get about 7 minutes of runtime per charge, but it'll likely end up being a little bit lower than that. I did not leave myself much space to jam in those batteries, and I had to rewire some connections as well as modify the battery casings a bit to make them fit. But even so, they just barely fit in there. And yeah, it was scary trying to close the case, because shorting the batteries would cause a fiery nightmare to say the least. Okay, everything's put together now. I guess it's finally time to test this thing out. But first I gotta put on my laser goggles.
Yes.
Because seriously, just looking at the output of this thing on a surface is definitely enough to burn your eyeballs out. Alright, so here's the main power switch. Then you can see the readout there for the battery voltage and then the temperature. Then right here's the safety switch.
It doesn't tell you how fast the laser's going. I'm sorry, I know I've made that comment already, but it... Come on, it's just so fun.
Arms the laser. Alright, here goes nothing. Wow, that's insane! Wow, check out how it lights up my whole shop there. Completely overpowers the light. Oh man, that's a scary amount of power. Wow. Now just to give you an idea on how stupidly powerful this laser is, I have a couple other lasers here to compare it to. So this laser right here is 5 milliwatts. So a direct hit from anything stronger than this is going to cause eye damage faster than you can blink, or even just a reflection off of a shiny surface. Now this laser right here is 500 milliwatts, or half a watt. So that puts it in the highest laser danger rating there is. So that means that not only is it a fire hazard, but just looking at the spot on a surface can burn your eyeballs out without goggles.
I think Styropyro needs his own class of lasers, maybe even multiple classes of lasers above that of 4.
And then there's this laser, which eclipses that rating 200 times over. I mean, seriously, there's no sane reason for something like this to even exist, and yet here I am, flaunting it on a YouTube video. Okay, so what can I even do with it? The same thing as any other gadget that isn't boring. Light stuff on fire. Check out how the raw output just torches my desk. I'm not even using a lens here. The power density is already way higher than my laser bazooka. As for the other burning
Did he say laser bazooka? That's awesome.
let's start with the easy stuff. I wonder how fast I can pop these balloons with the laser.
Probably don't even need to hit it directly. Yeah.
That never gets old. Let's try it on a paper bag. Huh. Well, that's terrifying. Geez, that lit on fire like nothing. Yeah, this thing is a lot of fun.
Man, I'm just trying to think of how you'd even get certified on one of these things. You need to go through the same amount of fire safety that you would go through for operating a flamethrower, I guess. And if you were to use anything like this, you would need like some kind of next level hot work permit, because it's more projectile than, say, a welding group. I don't even think that. Yeah, it just wouldn't be allowed. I don't know how else to get around it at a nuclear plant.
Can the raw output ignite wood?
That's a yes.
I'll take that as a yes.
That's quick too, compared to his other lasers even.
How about a ping pong ball? Alright, that's pretty cool.
Great balls
It
of
turns
fire.
out ping pong balls are surprisingly flammable due to their nitrocellulose content. Speaking of nitrocellulose, here's a little bit of flash paper.
Yeah.
Since I'm already igniting a bunch of random stuff, I might as well put that chemistry degree of mine to use and whip up something
Oh
exciting.
my. What is it? Of course. Whoa.
I love lighting stuff on fire.
It's wildfire from Game of Thrones. Sort of, not really.
This right here is one of my most requested laser experiments.
Steak.
Can I cook a steak? One way to find out.
He did in his laser microwave.
That smells so good.
Is he gonna eat it?
Listen to that baby sizzle. Huh, and you thought microwaves were bad at cooking food all the way through.
No.
Some people might ask, how hot is the beam itself? Well, the thing is, there isn't actually a Yeah, it's hot.
I thought my video cut out for a sec, but no, that was on purpose.
Okay, well the beam doesn't exactly have a temperature, but it certainly can heat up objects very quickly. Now, how hot depends on a lot of factors, but this piece of wood here heats by hundreds of degrees in under a second. Let's tackle another popular viewer question. Can I send electricity down the
material.
laser beam? To test this, I have a voltage multiplier stack that produces
Sure.
very high voltage DC. When the leads are close, the field is strong enough to ionize the air and cause an arc to form. But when they're further apart, the field is weak enough that the only current that passes is from corona. Now when I shoot a laser between
yeah.
the gap, there's no arc as the beam is not conductive. Now if the laser were millions of times more powerful, it could rip apart the molecules in the air to make a conductive plasma, but unfortunately I can't do that with this laser.
Nuclear fusion reactor that uses a bunch of lasers focused to a point. But yeah, it's just about, and think of it as more of like energy imparted versus like them having their own electric or heat. It's more of a targeted. It'd be a bit like saying, how hot is gamma radiation? Not really a thing, though it'll burn you if you absorb too much gamma radiation. Say the same thing about UV radiation, and lasers, also a form of radiation.
I can cheat a bit using fire though. By sticking some matches between the gap,
yeah.
I can ignite them with the laser to generate some thermal ions.
Essentially just close the gap.
What happens here is that these ions get accelerated by the field and then smash into other neutral molecules in the air, which generates more ions. This process cascades until you have a giant arc between the electrodes.
Now that's cool.
Alright, so the raw output of the laser is certainly impressive, but I still think I can do better. I wonder how much more damage it could do if I use a lens to focus down the beam. A smaller spot means more damage, as shrinking the beam size in half will actually quadruple the power density on the target. I mean, anybody
Inverse square law again, and again, that's how that fusion reactor works. Almost just under 200 lasers focused to a point, and that's how you get that plasma. The plasma, the heat, the pressure to achieve ignition or the start of a fusion reaction.
who's played with a magnifying glass on a sunny day can attest to this. But that being said, using a lens to focus down a laser ray does have its issues. Even from simple ray optics, you can see that a lens doesn't actually combine the beams, as it also images the gaps between them. Plus, you have effects like spherical aberration, and the fact that each individual beam is diverging.
Spherical aberration, or, as I like to call it, why, unfortunately, the Death Star would not work as designed. Yeah, what a mess. Proof that the Death Star's weapon isn't really a laser.
Isotropically to make matters worse. But the thing is, using any sort of beam correction on an integrated array like this is incredibly difficult. As far as lens systems go, I found what's probably the best option for the laser in a prototype projector I had sitting around. It's a big AR-coated F-theta lens that's rated for high laser powers. I made a mount for it using PVC fittings and then stuck it in front of the laser array. So how much more damage can it do? Using a piece of wood as a target shows that the beam shrinks to a fifth of the original size, which means a 25-fold increase in power density. And see how instantly wood ignites the beam. This makes it really great at engraving wood. I've never had a handheld laser that scorched wood so easily. There's nothing like a nice, refreshing bottle of soda after a long day of building death rays. But it looks like I forgot to bring a bottle opener. What am I supposed to do now? Oh yeah, I almost forgot. I can just use the most powerful handheld laser in the world.
I like how the thing looked like it had a big expander on it, but it was really just effectively a reducer combining all the things. It's just so cool.
Well, that's certainly frightening. Yeah, that's molten glass you're looking at.
Molten glass, that's some extreme temperatures. Kind of like during the Trinity atomic bomb test that turned sand into glass. I wonder if this will turn sand into glass. Maybe not.
That was probably the most metal thing I've ever done on this channel. I wonder if I can use the laser to burn DVDs. Huh, do you get it? How about some coarse steel wool? Ooh, pretty orange sparks. Okay, this one's total overkill, but let's cut some electrical tape.
Yeah, just satisfying.
That was pretty satisfying.
Wow.
Can the laser strip the paint off of this steel lid? One way to find out.
You can just write your name on it.
It works, but not very great. Actually, it seems to be damaging the metal itself. Okay, that's pretty ridiculous. I wonder if the beam can punch all the way through.
Yep.
Wow, that's crazy. I did not expect to see the day where I could shoot through metal with a handheld laser. Like, that's just unbelievable. It wasn't even that long ago that a blue laser of this strength would require the setup the size of a building to operate.
I feel for the poor guy who would attempt to break into Styropyro's, I was going to say house, but lab, complex, not sure what you call it, but he's got so many lasers and stuff.
So check out my massive argon ion laser that was made in 1995. Now by massive, of course, I'm referring to its physical size. The physics going on here is really cool, where the laser emission is coming from an ionized argon plasma inside the tube.
Yeah.
This particular system makes 9 distinct colors that are apparent when the beam is split up with a diffraction grating. But for all but just a few applications, the argon laser has been rendered obsolete by the blue laser diode. So why is that? This behemoth of a laser only outputs about 70 milliwatts, yet it takes a whopping 1,500 watts to produce that output. It's crazy just how fast laser tech has progressed. I mean, this laser isn't even that old. It's only a couple years older than my cat Putty Tin. Yet this handheld laser built in 2020 is well over 1,000 times stronger while consuming a quarter of the electricity, and also only being a fraction of the size. Now I think that's pretty cool.
Sure is.
While this laser is definitely pushing the envelope for power to size factor, I'm not the one who made this kind of build possible. This project is actually based on 2 recent Nobel Prize winning technologies. There's the lithium-ion battery that won the Nobel Prize in Chemistry in 2019, and the blue LED that won the Nobel Prize in Physics in 2014. Lithium batteries are incredible in their energy storage capabilities, and that's why they're used in our phones and laptops and pretty much everything around us. I actually used a small lithium battery to jumpstart a car last month. Then there's the blue LED, which directly led to the blue laser diode. The award here wasn't given for portable death rays, but instead for the highly efficient and long-lasting white light sources made from them. Without either of these technologies, this project would not have been possible, so the real credit goes to all the scientists and engineers who worked on this groundbreaking research. Now that being said, I'll happily be remembered as the nutcase that jammed a 100-watt laser in a handheld device. Now I do want to clarify my claim that this is the most powerful handheld laser in the world. I'm referring to CW here, because pulse lasers can have very high peak powers while having low average power. I built a handheld laser 4 years ago that had higher peak power, but only for bursts of 10 billionths of a second per shot. But for a continuous wave laser that you can hold in your hand with a fully contained power source, I'm fairly certain that this is the most powerful in the world. One last thing I should mention is that you don't have to get into record-breaking territory before lasers get dangerous. This 1-watt blue laser from eBay will damage your eyes by just looking at the spot, and would shut the lights out forever with a direct hit if you aren't wearing goggles. These $3 laser pointers from eBay can shoot a hole in your retina faster than you can blink, even without a direct hit, since they're usually way stronger than advertised. If you're interested in the hobby of lasers,
just goes to show you it really doesn't take much, and also buying stuff on eBay, you need to know what you're buying, and it's buyer beware for all of the safety protocols you need to be familiar with. And these are, what's great is that these are just so small, one click, can use it, can give it to a kid, whereas power tools generally require, well, some of them have to be plugged in for one, and some of them have like a double action grip on a chop saw, so it's a lot less likely for a kid to hurt themselves with it.
Awesome. With the right precautions, it's a very educational hobby.
That's pretty.
But my goodness, please read a bunch about laser safety before ever ordering a laser online. Alright, so that's all I have for you today. But until the next time, stay safe and happy lasing.
What is this? Might need some help on if this was a reference to something or... Yeah, I don't know. Thanks so much for the recommendation on this one. This was a lot of fun to watch, and it is crazy how fast things like laser technology, computer technology has advanced, and I would love to see that same development with nuclear power technology. Either way, this was a fun video. Thank you very much for watching. I'll see you next time.